Okay, I'm here with my DAT class, and I want to go over a question that I presented to the study group. I wanted to know in this problem, for those that don't know, this is an amino acid, all right? I wanted to know what would be the approximate value of the lowest pKa. Now, if you remember, a phenol had a pKa of about 10. We taught that in lecture. If you put a nitro group on a molecule, what does that do, Sam? What does the nitro group do? Right, it makes it more acidic, right? It makes it much more acidic because it stabilizes the anion. And we've gone through that. Notice that it brought it down to a what? To a 7. So I call this is sort of like the King Kong group. If you see a nitro group, it's going to really make the compound acidic. Let's look at this. Now, let me ask a question. We all know the most acidic group here is going to be the carboxy group, right? Now, what's the average pKa, Aaron Cohen, what's the average pKa of a carboxy group? All right, this kid's still asleep. I got to wake him up. Crystal, what's the average pKa? I only said it how many times? How many times?
A lot of times.
Only 100 times, Mr. Cohen. But anyway, it's about 5. Now, here's my question, and I want you to think about it. Everybody and their grandmother knows that the pKa of a carboxy group is 5. If you got it right, and that happens to be the answer, are you learning a lot from it or not really? The answer is no. We all know what the answer is. So if you bag an easy problem, it'll make you feel good, but you're not gaining any strength. So listen up. The pKa of a carboxy group is 5. And that's what everybody put down on the study group as a 5. But, Jocelyn, does anything good follow the word but?
No.
Why don't you listen up? Do you see this group right here? The NH3 group. What did I call, Mr. Cohen? What did I call an NO2 group? Nitro. It's a nitro group. What animal did I compare it to? All right, this kid's still asleep. King Kong. You never asked me about Godzilla. The Godzilla group is an NH3 plus group. That would be even more electron withdrawing. So therefore, as you can see, look what's going to happen. You're going to examine the anion, and there's the anion. All right, we know the pKa is 5, but you got a monster electron withdrawing group. And what do we call when we stabilize a molecule by withdrawing electron density? That's called the inductive effect. So you have a huge inductive effect, not only here, but on your next door neighbor. That's going to bring down the pKa to about 2. And there you have it. One of the choices was like -10. Don't get too carried away. -10, if you remembered, was those strong mineral acids, like HI or HClO4, but it really brought it down. So what have we just learned? A carboxy group comes in about 5. But if you have an amino acid, and that's what this is, right? It's got an amino group, and it's got a carboxy group. The pKa of a carboxy group in an amino acid is around 2-ish. Everybody follow me? So now you've gained strength. So I could have put up a simple question for you to make you feel good. But you're not gaining any strength, and you're going to be reduced to these idiots who do time tests, and you think you're there, okay? But in actuality, you've learned absolutely 0. So you wanted to walk away from this question, you got rammed on it. But nevertheless, you've all gained some strength on this. So if you have a group like a nitro, or now you know an NH3 plus group, that gives a gigantic inductive effect, and it really took that pK down from 5. It took it down 3 magnitudes of 10. All right, good luck. Bye-bye.